Welcome to another GC Basic demonstration. This is part 13 for the 18FQ20 family. In this particular video, we're going to be looking at SPI. I will be using a GLCD display to demonstrate the capabilities of SPI, both software and hardware SPI. What is SPI? SPI is an interface that's used between small devices on the microcontroller, such as a GLCD, shift register, sensors, or SD cards. They use a clock line. They use two data lines with an S, and say serial data out and a serial data in. They may also have a select line or chip select to help you choose from multiple devices that will be on this SPI bus. So your chip select, if it's high or low, the device will accept the commands. What we're going to do is hook up a little GLCD. It's an SSD, that's right, SSD 1331, and I'm going to use 5 connections. I'm going to use what's called the SCK, or that relates to the standardization name for a clock line, and the SDO, serial data out, and they're on port B6 and 5 respectively. And these can be controlled by software or by hardware. And that's the trick we're going to look into. With respect to other control lines for this specific device, this specific GLCD, we need a reset line, port C3. We need a chip select, port C.1, and a data or command line on port C.0. And we're going to have to specify those in our program so that the library knows them. And that will be the case for all the GC Basic libraries. You just need to specify these things. And how do you do that? You do that with some constants. And here it is. It says GLCD data out on B5, SCK on B6. And the other three, DC, CS, and reset on C0, 1, and 3. You might say, where's C.2? We'll look at that in a moment. But you just need to put these in the program, and the program library will expect these. And it will error out if you haven't defined them. If you do this, and you do it in software mode, things should work. However, things don't always work. They didn't work for me, because the more connections you have, the more trouble you're going to have. And I'm using this board I've got. I've also got flying leaves, and it came out that I had an error. It didn't work. Because I know some things I know. I know the GLCD libraries work. I know that it works. It works on other chips. So I was lucky because I have that confidence. You should have that same confidence. It's not likely to be a library issue, so work through the following checklist when it doesn't work. Check your connections twice. Check for continuity on every single connection between the port on the microcontroller to the input on the target device. I found that one of my lines was not working. It was broken. The wire somehow has become damaged. I threw it in the bin. Once I changed it, things burst into life. You can, and I have done this many times in the past, write a program to pulse a signal on each specific line, one at a time, and check it with a scope or other test controls. But test every single line if you're having issues. Then always use Software SPI to prove the basic functionality works. And then if you want to use PPS on the Hardware SPI, then make sure you've done step 3 first. Okay, you just need to make sure that everything's consistent. Don't just jump to PPS and hardware, expect it to work, and go, oh, it didn't work, pull hair out. Go back to step 1, check your connections. So we're going to look at using SPI and then hardware SPI. First thing I'm going to do, show you a video. And the video is because I'm having a problem with the lighting in here on the camera. And so I've recorded this on a laptop. Okay. So what we're going to see some text come on the screen like that. It's going to say SSD 1331, GLCD, etc. Then it's going to change the screen. It's going to write some text, put some numbers on there, change the color, blue, text, red, numbers. And then it's going to go into what I call the capability test, which shows strings being put on the screen and numbers and characters and circles and lines and boxes and things like that. And it's quite useful because it's a standard test. I can just look at that and go, yeah, things look okay. All right. And if you actually look very carefully, there's a little tiny box appearing as well. So, and it goes through color cycles. And the problem I'm having with the camera is the following. I'm getting a shimmer on the screen and I can't get rid of it. And I don't know how to. And I don't really care because on the lab here, it looks absolutely perfect. Let's look at some code. So I'll go into Zen mode. I've got my program here. Let's go from the top. Specification of the chip, option explicit. Pretty obvious what that means. I've got my hardware, and my hardware here is as per the diagram previously. I'm not going to go into that too deeply, but essentially, look, I've got down here, reset, chip select, and data command, and my clock and data outline. And they connect up to the wires that you can just about make out at the top of that camera. I've got a section of PPS, but I'm going to come back to that because I'm not using PPS. I'll prove that to you in a moment. Right, this includes the GLCD libraries. This method now includes just the base library, and then you need this line here to specify the type of library you're using, GLCD type, and I'm using a GLC type underscore SSD 1331. There are many different types. And these are my ports. These are my constants I showed you in the demonstration presentation, just to define these 5 ports. Clearly, you don't define 0 and the ground on VCC. They just assumed. And I have commented out this line here, look, is constant SSD 1331 hardware SPI. Commented out because it will force it to use software. The rest of this is on all the GLCD command set. And this is an example. It could be SDI card, could be any of the other SPI libraries. And it basically writes strings and things on the screen, and I'm just going to program it. And I'm now compiling it, and whilst it's compiling it, it will then go through the reset. And in the camera, you can see that the previous revision was running, and it's now just reprogram the chip, and it will reset it and start with our string. There we go. Clear screen, write some text on there. Then it goes to a nice steady blue on my screen, a nice beautiful red, and it is beautiful. I can't deny it. It's very strong red, and then back into what we were looking at. So why have I not? How do I know that that's using Software SPI? Let's recap. We know it's using Software SPI because we commented out this constant. If it doesn't exist, it will use software. So let's have a look what's inside of that PPS statement, because not all chips are PPS, but this one happens to be PPS. I've got my PPS commands here for the SCK and the STO, and I got those from PPS tool. And you can get to PPS tool by pressing function key F4, type in PPS, and I'll just drop the screen down so you can see it. How do I do that? Over there, look. Let me just do that again. Function key, PPS tool, and it will open up, and then you can select your PPS ports, and I selected serial data out on the ports we specified previously, and it puts these 2 entries in automatically. And then what I had to do, what you're going to have to do if you're going to swap between software and hardware, you're going to have to put in like a conditional statement, and this is called a conditional statement. Hash if def, this particular constant, else set these 3 registers to 0, and it will turn off SPI. Another way of doing it would be to power cycle the chip. But if you do not set those to 0 and you fail to power cycle the chip, they will not default to 0 and they won't get changed and you won't have software. The port or the SPI capability will have locked into the chip and you can't use it any other way. It will just be locked until you power cycle it or set it to 0. So in this case, it's going to, in a moment, I'm going to do this, put it to Hardware SPI. And the way I'm going to do that is just by uncommenting this line here. Before I do that there, let's just look at the performance of this thing. It's just going to 0 now, and it took that long to get to 10. So it's quite fast. Look, I'm not going to time it. Let's just see what it's like in. I should time it really, but I won't. We're not here to time things. So this is quite moving quite fast. It's going through the same demonstration in a moment, and it's going to recompile it. We'll see the chip stop operating whilst it's being recompiled and loaded, and then it will go back into the demonstration. And the demonstration and the library that's supporting that handles the hardware and software. And here we go, it's going through the same process of blue screen, red screen, and then it will end up in that demonstration. And you'll see that the numbers are slightly faster because it's less instructions to send the data out when using Hardware SPI. It's just less instructions. It's a deeper library, there's more stacks used in the library, but it's less instructions as on overall. Therefore, it is faster. And that just proves how fast it is. You can see it visually. So back to my presentation and wrap this up. We've had a look at Software SPI, Hardware SPI. Most of the GC basic libraries support that little constant that says the device name Hardware SPI. If it doesn't exist, it will use software. You can write your own programs using Software SPI, but it works quite well. So we've done our examination. We've done our examination. We've seen it working. I use GLCD as the example, and SPI works. Next time we'll look at pulse width modulations, probably do it 6 ways to dim the LEDs, and then we'll move through to more complex areas later on. Enjoy.